Greetings. Today we are going to demonstrate module 4 for demonstration of Pelton turbine. For the first step, we will need to turn on the power supply, and then we will turn on the switch for this machine. And for this experiment, we will take 3 water pressure, which is the first one is to the half turn. Then we will proceed with adjusting the steer valve until it reaches 1.5 psi. And for the next step, we will need to adjust the spring top until it reaches 200 rpm, and we will use speedometer to track it. And we will repeat this step with other rpm for 400, 600, 800, 1000 and 1200. For the next step, we will close this hole like this, and then we will take value from the flow meter, starting from the first reading until it's reached the fifth reading. We will stop. After that, we will stop the timer and take down the time for each RPM, and we will repeat the same procedure for the full turns and full and half turn. That's all for the experiment.
Moving on to the apparatus of the experiment. The first one is Pelton turbine apparatus. This is the Pelton turbine apparatus. It consists of turbine wheel and nozzle, which convert the kinetic energy of water into mechanical rotational energy. The rotation of the turbine can be measured to study its performance. Next, hydraulic bench. Here we have the Salted FM 110 hydraulic bench. This centrifugal pump apparatus supplies water at controlled flow rate and pressure to the turbine. It allows us to simulate different operating conditions safely. Next is tachometer. This is the tachometer. It is used to measure the rotational speed of the Pelton turbine pulley in revolution per minute. Accurate RPM readings are essential for calculating the turbine's performance. Finally, we have the stopwatch. This is used to record the time taken for a certain volume of water to flow or to measure other time-dependent observation during the experiment.
So for the variable for this experiment is manipulated variable is water pressure. Constant variable is pressure gauge, and the last one is responding variable is spring torque.
The expected outcome of the Pelton turbine experiment is the student should be able to determine the mechanical characteristic of the Pelton turbine and evaluate its efficiency when the hydraulic energy of the water jet converts into mechanical energy. In this experiment, turbine speed RPM, spring load, and time taken for flow meter to collect 4 liters of water will be measured. That will be used to calculate the total brake force, flow rate, torque, the brake power, and turbine efficiency. Using the value gain, the performance curve graph can be plotted, which is torque versus turbine speed, brake power versus turbine speed, and turbine efficiency versus turbine speed. From the acknowledged curve, the value for optimum operating point, where the turbine achieves maximum efficiency, can be determined. Finally, the experiment aims to provide a clear understanding of the relationship between the hydraulic and mechanical energies in an impulse turbine and the factors that affect its performance and efficiency.
So for safety, today I will briefly talk about the safety aspect of our Pelton turbine experiment. First, the most important safety point is handling water around the electrical equipment. Since the turbine's setup use a pump, sensor, and electrical panels, we must ensure the area is dry at all times. Any water spill should be cleaned immediately to avoid electrical shock. Next, the turbine rotates at high speed, so we must keep our hands, clothing, and tools away from the moving shaft and belts. Before adjusting anything, We must switch off the pump and wait until the rotor fully stops. Then we also need to make sure all hoses and connections are properly tightened to prevent the sudden water burst or leaks. Wearing a cover shoes is required to avoid slipping on wet surface. Finally, we must follow the lab instruction and use the emergency stop button if anything abnormal happens, such as vibration, noise, and unstable flow.